morning, everyone. I'd like to introduce you to our roundtable discussion on the issue of new skill sets for young researchers in the 21st century. You might be surprised to see that we don't have on our panel very young researchers. We have mid-career researchers, or even people like me, end-of-career researchers. But what we are potential employers of young researchers. And the reason for this panel composition is that we're interested in the opinions of potential employers who will be hiring researchers in the next few years and what they feel are the new skill sets that are required. I hope that there are a lot of young researchers out there on the virtual platform to listen to this session, because it's interesting to know not only what you are bringing to your employer, but what your employer might be expecting of you. So that's what we are trying to do with this session. We are aware that things are changing in the world, and the fact that academic and industrial research is no longer being operated the way it was a few years ago. Progress has been made in a number of areas, including the areas of robotics, machine learning, and artificial intelligence, et cetera, which are facilitating in some ways the professional activity of researchers, but at the same time are making it a little bit more complicated. We're also thinking about the fact that the widespread use of data, open data, putting data out on the web is sometimes leading to a flood of data, and using that and doing it appropriately is also a challenge. In addition to that, society has now got greater expectations of researchers, whether they're in the public sector or in the private sector, and the issues associated with responsible research and innovation, research integrity, and more generally, the impact of what people are doing are becoming more and more important for society, and asking the research community to look at that more carefully. So what we wanted to do today was to see how over the last few years the expectations have changed and how the skill set needs to be modified to allow the new young researchers to be successful in their careers, whether they're in the industrial private sector or whether they're in the academic or public sector. So our panelists, let me introduce our panelists. So myself, I'm Michael Matlos. I'm a professor at the University of Lorraine in Nancy, France. And I'm also the president of EuroScience. And we at EuroScience are particularly interested in the professional development of all science professionals. And that's one of the reasons why we feel at ESOF we need to really concentrate on the things that are important for researchers' careers. Our second panelist is Grazia Ritadini, who is the Chief Technology Officer of Airbus, a multinational aerospace corporation. And so we're interested also in the international aspect of what is happening in the changes in the skill set. Our second panelist is Maria Makarov. Maria is the director of BioCenter Finland, which is a group of a national network of 6 universities and 5 biocenters. So we're very interested in how the academic community is looking at the new skill sets and the new ways of working. And our final panelist is Patrick Maestro, who is the Chief Scientific Officer of Solvay. Solvay is a Belgian-based multinational corporation specialized in materials, solutions, and chemicals. So we have also a wide range of sectors, from the bio industries and bioacademics to the aerospace industry and to the materials and chemicals industry. So we see that we also have a wide range of sectors and also a wide range of expectations. What I'd like to do now is to allow each of you to speak for 5 or 10 minutes about your initial ideas about this particular area. And I'd like to start with Grazia Ritadini from Airbus. Can you give us an idea, Grazia, of your ideas in this area?
Thank you. Thank you very much, Mike, for the warm welcome and for the introduction. Buongiorno, Trieste. Good morning, everyone. It's a real privilege for me to have the opportunity today to be among all of you, thinkers, technologists, innovators, and researchers. So really some of the brightest minds that European science has to offer. You know, when I started my career back in the early 2000s, I was a young engineer who was witnessing a very exciting time in the world's exploration of human flight and space discovery. We had the first manned supersonic flight. We were putting in the skies the world's largest airliner, our iconic A380. We managed performing the first ever surgery on a human in zero gravity conditions. Just to name, right? The three um, exciting outcomes. At that time, even the world outside aerospace was ushering in a very rapidly changing decade, a decade where I believe innovations were defined by human curiosity and by interconnectedness. Three words specifically come to mind when I think about the defining characteristics of research and innovation back in the days. First of all, speed, fast. Time was of the essence, right? Mediums and devices such as, YouTube, we had the Amazon Kindle coming up, Skype, the iPod. Do you remember the iPod, the infamous device that put I don't know how many thousands of songs in our pocket? All this brought rich media content right to our fingertips whenever and wherever we please. The second concept is definitely open. Evolution of the concept of social networking. We had Twitter, Facebook. This all created a reality in which anyone had the freedom to exchange pretty much anything online with anyone they chose. And finally, I'd say focused. The emergence of this devilish device comes to mind, not because it gets most of our focus every day, but because to me, it really represents how advances in technology delivered a focused response to quickly evolving human needs, connecting to faster 3G, 4G networks, for example, or enabling game-changing GPS functionalities like location services. But okay, reliving some tech nostalgia is nice, but let's face it, the world is just not the same place it was 2 decades ago. The world is not the same place it was 2 months ago, let alone 2 months before that. So our question today is, what skill set does a post-pandemic future demand from an aspiring researcher, technologist, or innovator in the 21st century? And the answer is pretty straightforward, really. On one aspect, I'd say nothing different than it did in the early 2000s. In fact, the crisis forged by the coronavirus has made it all the more clear the need to be fast, open, and focused. And let me briefly elaborate on why. Fast, because in the 21st century, technology evolves at a hyper speed. The increasing pace of research and development gives me a lot of confidence. Digitalization has created opportunities for virtual modeling and testing, for instance, that would have simply astonished previous generation. Add into that the algorithms, the potential of artificial intelligence, the power of quantum computing, and you're looking at a complete tool set to improve and accelerate our processes far beyond anything we could have imagined even a few years ago. However, as far as R&T goes, research and technology, some could say this unprecedented pace confronts us with some, let's say, commitment issues. And what I mean is that, gone are the days when we can remain in a committed relationship with a specific technology development throughout the course of our careers. We simply would never be able to keep our skin in the game, certainly not from industrial level perspective. So to face our commitment issues in the R&T project life cycle, we need to shorten the life cycle in the name of staying relevant. And as a byproduct, we will see more and more how the success of R&D will be measured by which terms we can collaborate, develop, and deliver at hyperspeed. Take an European EU collaboration project, for example. A project lifecycle could typically span 5 to 6 years. In today's technology, industrial technology universe, 5 or 6 years may as well be a lifetime. And the risk of not moving at this pace are countless. Projects could lose relevance. Europe could lose its sovereignty. Alternative solutions or technologies may become available, making us obsolete. And of course, when you move quickly, you fail also more quickly. But if you ask me, creativity does need this type of stubbornness. At Airbus, our upstream research teams operate with a project duration timeline of 2 years maximum. And how do we achieve this? Well, keeping our researchers focused on demonstrating key technology projects and constantly and transparently measuring the results against milestones to be achieved. Open. Leonardo da Vinci, one of my favorite engineers, said that learning is the only thing the mind never exhausts, never fears, and never regrets. And in my view, 21st century researchers need to continue being inexhaustible learners with curiosity about what's developing around them, fearless to navigate also uncharted waters and opportunities, where, of course, a profound scientific skill in their area of expertise is imperative. But just as important is the ability to understand and to be open to the expertise of others. Without this openness to the expertise of others in the R&D community, we, I fear, will not be able to find the best possible solution, because the best possible solution is very often not singular, rather it's a convergence of several technology bricks. Last but not least, focused. As we progress through the 21st century, our researchers need to have the ability to focus on our true business and industrial needs. In aerospace R&D, this means understanding our industry well enough to discern which technology advances can have the maximum impact on the aerospace industry. And when we look at all the promising opportunities and areas to develop that have potential to show true business benefit, it can feel like, like drinking from a fire hose, hectic and overwhelming and sometimes even uncomfortable. So it's really key, in my view, that researchers, and many of you in the virtual audience today, hone their ability to prioritize and focus on the opportunities that will be the greatest game changers in our business for the future. And to my teams, I often recommend that they start looking also inward, studying, learning, and gaining a broad understanding of what their particular area of technology can bring to the table when it comes to influencing the aerospace industry of tomorrow. So as a closing note, looking at the uncertainty and the complexity of our world today, let's remember that there's still many reasons to be excited about the future of work, of research, and of continuously learning. Let's not forget to harness our collective ingenuity and innovation to really continue progressing in the name of science. And let's deliver the new generation a world that's not only brimming with technological and societal breakthroughs, but possibly one that is better than today's. So thank you so much for having me today. I really look forward to a fruitful discussion with all of you.
Thank you very much, Grazia. And for being perfectly on time. This gives us an opportunity now to pass on to our next panel participant, which is Maria Makarov from the Biocenter Finland. And Maria, since you're the only one of the initial panelists to talk about the academic sector, I'd be very happy to hear your thoughts on perhaps also the differences between what's expected in the academic and industrial sectors, or similarities between the skill sets required to succeed in that other area.
Sorry? It's fine. Thank you very much, Chair. So it's a real pleasure to be with you today. So indeed, I represent the public academic sector together with our chair. And let's remember that the university institution is more than 900 years old and the oldest still living institution after the Catholic Church. So the universities move very, very slowly. Let me start with the basic at the Finnish national level in a very, very concrete way. So the renovation of study paths leading to industrial and the academic careers got a real kick-off start in this country 10 years ago when the University Act was renovated. The aim was to modernize the Finnish university system to achieve higher quality of research, better transfer of knowledge, and more efficient study paths. To achieve this, the universities, which were part of the public administration, were detached from the administration to become highly autonomous legal entities with total independence what concerns their strategy development, the use of the block fund received from the Ministry of Research and Education, independence in HR policy, no civil servants anymore, but employees, and in the design of study paths. I give you a concrete example now of the results of this university modernization action. Now, the flagship of this reform is the Aalto University, named after the famous architect Alvar Aalto. It is now 10 years old and has been, I must say, hugely successful. So Aalto's inspiration is to capture new opportunities for education, research, and innovation from the interface between technology, business, and art and design. So I give you one specific example of Aalto's 2-year master programs, and this one is entitled Creative Sustainability. And this is an example how education moves from monodisciplinarity to multidisciplinarity. So this particular master's program now aims at students to acquire a multidisciplinary mindset from the very start, courage to seek new solutions to solve global challenges, and new skill sets, such as ability of systems thinking in problem solving, cognitive flexibility and design thinking, extensive analytical skills, understanding of sustainability management, and this in the area of circular economy. Next, I would like to give you another example, which is now a master's program in mathematics and systems plus operational research. So the math section now provides expertise in mathematical methods needed in research, industry, and society, very important. Solid math background in computation, machine learning, and for instance, quantitative finance. The operations and systems research sections provide skills in optimization, statistics, forecasting, simulation, decision-taking, risk analysis. I chose the math example for a reason. Now we must abandon the perception of math with only 2 major career options. First, genius math scientists reaching for the Fields Medal, or sort of degradation to becoming a school teacher in math. This thinking is what has kept female students off the mathematics departments. Now, math skills are needed in many, if not most, sectors of society. And we, of course, need all talent. Therefore, please, us, everybody, we must do everything to inspire girls and female students to embrace math, because, of course, diversity increases collective intelligence in any circumstances, in any active bodies. And of course, for women not to be excluded from major global job markets that are close to those lacking mathematical skills. Now, I will move to the European level and would like to highlight 3 EU programs that address the skills of tomorrow, the theme of this particular panel session. First, the European Institute for Innovation and Technology, the EIT. The EIT's mission is to create cross-border innovation ecosystems in Europe. And in these ecosystems, higher education, research, and innovation are combined. EIT is a thematic organization, so it is organized into thematic hubs in 8 technology areas: energy, digital, climate, food, health, advanced manufacturing, raw materials, and urban mobility. Now, these thematic hubs and their nodes cover almost all EU member states and associated states. Now, concerning the education mission of the EIT, it partners today with 65 of the best universities in Europe, and we know that there are 900 higher education institutions on this continent, and with industrial partners in provision of training at the master's and PhD levels in these 8 technology areas, combined with entrepreneurial education, and that's the key. Each course is run in 3 universities located in 3 different European countries. And this is a great inspiration for the students. There are huge application pressure. So far, 3,000 degrees have been rewarded, which are now EIT labeled degrees, but of course the universities are behind these degrees. Now, my second program that I would like to highlight is a new EU program, which is still in the planning phase. And this program aims at increasing the innovation capacity of the European universities by spreading the EIT education program to more than 400 higher education institutions in Europe. We all understand that this is a huge task. The third example and last example is another EU program which is already up and running. It has been called the European Universities Program. And in this program, universities in different countries are inspired to self-assemble into alliances, which then carry out joint cross-border activities in education, research, and innovation activities. Thank you.
Thank you, Maria. I'd like now to pass over the floor to Patrick Maestro, the Chief Scientific Officer of Solvay. So Patrick, you're the third one to speak. So you have to make sure that you're very innovative and original ideas are not the same as Maria and Grazia. So good luck, Patrick.
Yeah, thank you, which will be difficult given already what Maria and Grazia have covered. Anyway, we'll try. So Solvay is a chemical company, more than 157 years old, so quite a big track record in chemistry. We are a chemical company, and we are serving many markets through various technologies. We provide compounds as different as hydrogen peroxide, sodium carbonate, surfactants, solvents, dispersants, but also very high specialty polymers and composites. And inorganic chemicals, so a wide range of products that serve many markets. We go in different markets like consumers, agrochemical formulations, cosmetics, aromas and fragrances, automotive, aerospace, building materials, energy. And so to serve these markets, we need, of course, a very good chemist to do the chemicals, but also we need people that understand the markets and the needs of our customers. Customer is key for a company like Solvay. If we don't provide products that our customer are willing to use, we are dead. So in terms of, so we need innovation, of course, innovation, and I will use a word that Grazia has been putting in, of course, speed. When I'm rather old in the career, and I've been experiencing 40 years ago, we were doing science and we were trying to apply the products with the 3, 5, 10 years horizon. Today, the speed is key. And so that will be one of the key points of the mindset of our researchers. But I will come back to that. So in terms of competencies, we are a chemical company. So we need chemists and chemical engineers because we need to do the products and we need to build the plants to do these products. But we need also people that understand the business and the applications of our customers. So we need physicists, we need polymer scientists, we need material scientists, we need physical chemists, because these are the people who are discussing with our customers, with the R&I organization of our customers, what are their needs and how we can translate the products that we are doing in function by formulation. So we need to be able to do composite materials. We need to be able to do formulations using our products to see how our products will deliver the solution to the customer. So wide range of competencies. And in each of these competencies, we need specialists, very high skilled specialists in all the competencies. And all the trick that we have in research and innovation is, of course, to put all these people together to work on projects, and where the people will define the target with our customer and the people will do the products that will meet the target. So it's not easy because, of course, it's a wide range of competencies and the people have to understand also how to speak together. But this is the trick and this is the key for the innovation. In terms of new developments, new skills, of course, we have already been discussing about digital. If I would put two big changes in the last 5 or 10 years, digital is one, and sustainability taken at large is the other one. We need more and more bio-based products. We need more and more circularity, and this is key for us and for our customers, because our customers are also willing to develop more and more sustainable products. So in this case, that means that we need also to integrate these competencies. Sustainability is more a mindset. You do sustainability, so chemistry. Chemistry is one of the key areas to bring more sustainability by the development of bio-based products, by the development of recycling, owing to chemical processes. So I would say for us, it's just business as usual. We know how to do that. It's just a matter of finding the good targets and finding the good resources to enter in our processes. Digital is more complicated for us, of course, because we are discovering that. We have been doing some modeling in the past, but again, to speak about speed, modeling techniques have evolved considerably fast in the last years. And what you could not model 5 years ago is now very easy. You can do that even on your smartphone. So we need people to be very reactive to these technologies because they are going at light speed. And we are involved now in our teams, people with skill in machine learning, in modeling, in robotics, in all these technologies related to digital. And so again, we need to have specialists of these technologies that we will integrate in the chemical company, and people with skills in modeling, machine learning, digital can and need to apply to us. We need these kind of people. And we need our classical engineers, I would say, or chemists, physicists, or material scientists, to be able to discuss. It's always a point of the link between the various competencies, because if you don't understand what the people specialist of machine learning is talking to you, is telling you, then you are in trouble. So it's always a matter of combining all these kind of competencies in our company. And I can tell you, when I entered my first chemical company, which was Ron Poulenc at the time, a real French company, we were almost all chemists. I was probably one of the only one that was with a material scientist profile, kind of an exception. Today, we have maybe 50% of our chemists, of 2,300 researchers. Probably 50% are chemists and 50% are with these different skills, and we will more and more integrate these kind of skills. Now, in terms of mindset, we need people, not only very good scientists, that's the basics. We need high-level scientists, but we need the mindset of innovation. We don't want the people to be involved in doing the best product and spending time in improving the product if there is not a need from the customer, something that the customer will buy. And again, back to what we have been doing in the past, we're really moving from the technology push that some of the companies have been involved in the past, to really the market pull, to what is the need of the customer. And as Grazia was telling, the customer is evolving very fast. So we need to be very reactive. So this is also one of the points in the mindset of our researchers: reactivity, changing, going fast to new projects and killing fast the projects that are not useful for our customers. And this is really something which is new, because all the education, most of the time you're doing a PhD, you are working on the 3 years project and you want to achieve something, and you think you have time. When you are going to industry, it will be changing, and it's changing more and more. So innovation, mindset, speed, and opening, the same. I'm not original in this case. Opening to the external world, whether it is our customer, whether it is academic world, whether it is startups, everywhere you can find something that you can integrate to present a good solution to your customer. So don't work only in your lab, really be open. You have now all the tools to get information. The same in the past, we were looking to big books to look for information. Today, in 15 minutes, you can get all the information on the topic. So use this information. Make sure that it's a good information. Be very selective and appreciate the quality of the information, because the drawback of that is that you can get many information, but not all is always verified. And again, if I would resume in one word, is excellence. What we need is excellence in the way you do the job, and being very very demanding on. We are very demanding on what you are getting at the outside of the output of your work. Really excellence in science, excellence in what you are doing, and this open mindset. And of course, being ready and not only ready, but demanding of new tools, because the world of technology is evolving very fast. So look to everything that is occurring around you, and integrate that to deliver your solutions. I think we'll stop here, and I will be open to a question or comment.
Okay, thank you very much, Patrick. We now to have a short session where we'll pick up on the introductory remarks of each of you, and to try to go into a little bit more depth about how you see these things. One of the questions that has been important to me over the last few months of thinking about these things is we're now in the year 2020. So this means that we're not just entering the 21st century. We're already 20 years into the 21st century. Marx mentioned a few nostalgic recollections about new technologies in the early 2000s. But I was going to ask Maria Makarov, in the academic area, you said, for 900 years, everything moved slowly. And then 10 years ago, Finland decided that things would move fast. How has that changed expectations? For example, when we're looking to recruit new young faculty, what do we need that we didn't need, say, 10 years ago? And what are the things that we are still looking for? And what are maybe things that have changed a little bit in the way we are looking for them? Can you make a comment on that for the academic area? Because you may have been yourself involved in panels to recruit new faculty or in certain places. I suspect we're not looking for exactly the same attitudes, the same approaches, but in some ways, maybe there are some invariants despite the massive changes that we've had over the last few years. What are your thoughts on that?
Yes, thank you very much, Chair. So some keywords, and they are not ordered logically. These keywords have most of them already mentioned. So this multidisciplinary understanding, not narrow expertise. Of course, like Grazia said, I mean, real expertise in a specific scientific area is key, but then this multidisciplinary appreciation and understanding of what multidisciplinarity means. Mobility is searched. I mean, if you have spent all your, education in one single place, that is not as good as if you have moved. And there are two kinds of mobility: geographical mobility and sectorial mobility, industry, academia, or different domains in science, in research, and of course, then from country to country. That's very much appreciated because, of course, it widens your understanding and visions. Now, I would also raise work-life understanding. So now we have a new legislation here in this country which allows now the Hochschule, the polytechnical universities, which do not concentrate on research, but on work-life oriented education. So a student can choose modules from, a university student can choose modules from those curricula as well to complement his or her paradigm-based education with work-life oriented education. That's very valuable. Then industry academia collaboration at the master's level, at the PhD level, internships, that is extremely important. And there are countries in Europe which are doing this already very well for a long time. But in Finland, if there is something that we are not doing well, this is it. We need more university industry collaboration in education, in internships, and in research as well. So then I would like to mention the ability to learn, and this is what Grazia highlighted. That's absolutely crucial. And then to top this list off, an appreciation to other disciplines as well. So those in technology areas, in life science, in biomedicine, for instance, and I have that experience, don't know about humanities, research, scholarly disciplines, social sciences, and they maybe don't appreciate that area. But today, technological solutions are not enough. We must have expertise there which knows how society works, how people behave, and only in that way can new technologies be absorbed by the society. Thanks.
Yes, thank you, Maria. I had a question I wanted to ask to Grazia, which is a little bit more not your expectations, but more your observations. And this has to do with what I call the digital natives. I have 3 children, and my youngest daughter was born in the year 2000. So it's very easy to remember how old she is because you know what year you're in. So she's 20 years old this year. And I have the intuition that it's an intuition, I don't have any proof for this, but that there are differences in the way that this generation is going to be acting. They grew up with internet, they grew up with digital technologies, they're very familiar with them from the start. Of course, my daughter is still a little bit too young to be getting into her final professional career, but for those who are maybe 25, 30 years old and that you have encountered, Grazia, in your career, do you see differences between, for example, someone who's 30 years old today and someone who's 40 or 50 years old, in the way they're working and what they're bringing also to your company?
Yeah, no, it's a very very interesting and pertinent question, Mike. What we see is that in general, so young researchers entering the market today tend to have also different motivations. So they are looking for a sense of purpose. It's not just a matter of paycheck, but really they want to be part of something bigger than the industry itself, to be part really of a transformation effort towards, let's call it, the bigger whole. And so more we see a predominance more and more as driver really of key societal topics. Take sustainability, for instance, so environmental sustainability in aviation, for example, how to reduce emissions, how to embrace really
Yes, yes, yes. I think Grazia is coming back now. Okay, what I suggest then is, could perhaps,
yes, there was a
oh,
glitch.
here comes, Grazia is back.
Yes.
Okay, Grazia, you were lost for a minute. So when you left us, you were talking about the question and no connection. Okay, well, I would suggest then is that perhaps Patrick, you could pick up on the thoughts that Grazia was talking about regarding the bigger whole and the sustainability issues, which I know are important also in Solvay.
Yes. Well, sustainability is key. Of course, it will be the key element of the development of society for the years to come, and it's going also at high speed because again of the needs of the society and the needs of the customers. Now the solutions are not easy because today the solutions based on bio-based chemicals, for example, are always a bit more expensive than solutions based on oil-based chemistry. And this is one of the key issues: is how can we develop a real bio-based industry that would fit the requests of the society. So we have two ways. The one way is to go for innovation and to continue and we will in the medium term be able to provide bio-based polymers and or bio-based surfactants that will give the same property as the ones that we have today. But in some cases, we will not be able to do that, and we'll have to accept that we'll have to decrease in the performance in some areas. So which is a big debate. The other part is also to continue treating oil-based resources, but emphasize on the circularity, on the recycling, and finally decreasing the impact on the environment by this more circular economy. So it's a very big problem for the future, and this is something where we have to put a lot of efforts all together. And again, we need to have the input from academy because the people are working from the synthetic biology to bio-based chemistry to processes, and it's by joining all the forces on that, and it's a key element that we will really develop the global integrated circular economy and decrease the impact on the environment of sustainability through sustainability. This is a global challenge. It's societal challenge, but of course it's industry and academia challenge, and we need to work on that. And back to the other topic, which is the digital. Digital can help because, as Grazia was saying, I'm also very impressed to see how the young people are working. And by using this modeling, machine learning, they are going very fast in setting up the tools and setting up the experiments that will allow us to possibly improve in this in the integration of sustainability. And of course, we need, as industrialists, to have goals and indicators, and we have set up these kind of indicators within Solvay and all other companies have, in terms of how are we progressing in sustainability and decreasing our impact on environments. It goes from the chemistry, from the processes, from the way we do the materials, and for the way we are also working more locally with our customers.
Patrick, when you're hiring a new researcher, what are you looking for in terms of is there any way for you to determine, for example, with respect to some of the remarks that Maria Makarov made, the importance of previous mobility, geographic mobility, sectorial mobility, the fact that they have had either a disciplinary background or a multidisciplinary background, this kind of thing. Are there things that you're looking for today that when you're interviewing people, when you're hiring them? And then what Grazia said, the expectations of the candidates, looking at, they have a different value system perhaps, and looking for compatibility between the value systems of the candidates and the company.
Yeah, definitely. And I was very interested by what Maria was telling. We need specialists. I say we need the top level scientists in the areas. So that's where I'm less concerned by multidisciplinarity, because we need multidisciplinarity in the projects. So the way we address multidisciplinarity is by putting together very different people and working them and making them work on one objective. In terms of training before, it's important that the people are a bit exposed to multidisciplinarity, but this would not be my main focus. The main focus is really excellence in science, excellence in the field they have been doing their PhD or their studies. Mobility is great. I'm completely support that. It's much better we see someone who has been doing postdoc or even during his career from the early stages moving. So that's because it's related to the openness and the fact that the people are really open to change. Mobility in terms of technology, in terms of moving from one area to the other, as long as it's done well, I think it's also a very interesting point. And finally, the other point is again this what they are willing to do. Yes, when I interview the people, of course I focus on the quality of the science, but I'm very interested in what is their real aim in terms of what they want to do in their career, why they're joining a company like Solvay, and what they want to contribute to mankind, because I think it's really the purpose of what they have in their career which is important. And it's true that if I see someone who is just coming here to get a good position and to be quiet for 30 years in the company, because the big companies are usually something that people are seeing as long-term employment, I would not rank him in the first one position. Again, this kind, I don't care. Finally, of course, when I hire good people, we want to keep them, but we also are very open for them to move to our customers, for example. Many people from Solvay are moving to our customers, to move back to academia. I think we are missing also this link. We have very strong links with academia. Most of the time it comes academic people going into industry. Much less, I know in the northern countries a bit more, but in 1,000 countries we are missing getting people from industry back in academia. So this is this kind of mindset and purpose that I'm looking for in the young people joining us.
Thank you, Patrick. It looks like maybe we have Grazia back with us. Is that true, Grazia? Are you back with us?
I am back. I switched to my smartphone. Yeah, I mentioned digital knowledge and my connection broke. Apologies for that. So,
okay. Well, I'd like to tell you, just to remind you, Grazia, where we were with you. You were talking about the sense of purpose and the bigger whole, and
yeah.
you mentioned the sustainability agenda in that connection. And then we lost you, and so I had to improvise, and I passed the floor over to Patrick because
Yes.
he is particularly concerned by the questions of sustainability. And then I picked up with Patrick the question about what he's looking for. And then we found our first sort of slight disagreement between the panel members, because Patrick is not so concerned about multidisciplinary training programs. He's more concerned about forming multidisciplinary teams. And so what he was most interested in, and what Maria Makarov talked about, was the question of mobility, sectorial mobility, geographic mobility, openness to different types of things, going back and forth from one position to another. So maybe it would be interesting for you, Grazia, to tell us a little bit how you see the needs and challenges of higher education in this context, because Maria talked about the idea they have in Finland of multidisciplinary programs. I'm not so sure that Patrick would be so enthusiastic about them. He might be thinking about the idea maybe of improving the skill set in dialogue, discussion with people from other disciplines, but also maintaining perhaps some disciplinary aspects. I'm sure that Maria would not disagree with that. There has to be some basic disciplinary background in each of us, but I think it's a question of degree. Maybe it's a question of where you put the cursor between multidisciplinary and single disciplinary programs. So maybe you could comment on that, Grazia.
Yes, I can. I'll be glad to. From again our industry perspective, I believe the good news is that we need everyone. We need diversity, also in terms of background and education and skill set. So, in our industry, we put safety first always. Okay, regardless what type of new technology we're developing or configuration, architecture, propulsion technology, safety comes first. So there are risks if you do not build diverse teams, not only in the mindset, but in the gender, certainly to harness on Maria's words earlier on, but also in terms of background and educations, there's risks if you do not build diverse teams in terms of possibly not spotting mistakes, which could then really hamper safety of what we're doing. So indeed, integrity of research shall never be compromised. Yet the versatility that we are asking scientists to embrace is not only to be able to pivot from one project to another within their area of competence, but also to be able to understand, and Maria said it very nicely, I believe very pertinently, to understand. You need to appreciate adjacent fields to your own, and you need to be open to integrate at the end in new environments, in new products, whatever it is that your own area of knowledge and expertise produces. We see more and more, we are harnessing on researchers in fields which are not originally and exclusively aeronautic disciplines, electrification, connectivity, all related to data management, artificial intelligence, quantum physics. Be it computing, be it communications, these are not disciplines exclusive to our own fields. But when it comes to integrating the products of these disciplines into an aircraft, well, that takes versatility, that takes appreciation of rules, regulations, of architectural constraints, which are specific to our industry. So indeed, we need multi-skills, but we also need very specific expertise and academic, let's say, excellence in dedicated fields, which then where versatility has then another let's say repercussion, has another meaning, right, from the industrial viewpoint.
Yeah. Sorry, I inadvertently muted my microphone. I'm sorry about that. Yeah, so thank you, Grazia. I just want to, before we start the question and answer period, I just want to come back to this, I would say, disagreement. There's a slight disagreement between Patrick and Maria concerning single disciplinary issues. And I'd like to give Maria an opportunity for rebuttal here, because I think it would be good for her to explain how she sees these multidisciplinary programs in Finland, and how she understands them in the spirit of what Patrick was saying.
Well, we are not really disagreeing. So we need T-shaped experts and expertise. Okay, you have the basis in a specific scientific discipline. You're an expert there, but then you need this horizontal layer which touches upon those issues that Grazia just summarized. So of course we need the traditional specific scientific teaching, and that happens in this country as well. But I highlighted the multidisciplinary aspects because, 10 years ago, nobody talked about that, here at least. So this is a new dimension that some universities, not all in this country, have adopted, and it seems that it's a sensible way to go. So there's no real disagreement, Patrick.
I agree. and if I can comment, multidisciplinarity will come also during the career of the people, because they will be exposed to several different projects during their career and exposed to other. I'm a solid-state chemist, and I've been involved then. I'm not an expert, of course, but I've been involved in polymer science or organic chemistry. So this will come. So, globally, we need everyone to ask Grazia. And it's just a matter of where you put the cursor, depending on the kind of people you are looking for.
Okay, thank you, Patrick. Thank you, Maria. I think this just for everyone who's currently connected to our virtual session, to point out that the kind of debate and exchange that we just had between Maria and Patrick is a clear illustration of what we're trying to do with EuroScience and developing dialogue. What you saw happen was that Maria presented something on a certain level, and then Patrick represented something on a certain level, and they seemed to be in contradiction. And you saw how Maria got out of that contradiction is she added a second dimension. So if you think about the top of the T, that's a one-dimensional approach. If you add the vertical line below the T, then you bring in a second dimension. And actually, we're living in a world of infinite dimensions, and I think that we should not be looking at paradoxes and contradictions as a frustration, but rather as a source of inspiration for us to find ways to go out and develop our relations. That's the idea of the open forum, and so I'm very, very happy that our session here has sort of led to that kind of a very, very nice exchange, and of course, also very courteous, and that's very important as well. I've got a couple of questions now from the audience that I would like to ask each of you to address, and one of them is a really excellent remark. One of the people who is currently connected to our session would like to know from each of the three of you, as potential employers, what would be a key question that you would ask a candidate when hiring a researcher? Maybe I'll ask, I don't know, maybe Grazia could start.
Well, I'm an engineer. I'm very curious about science, so I'd be very keen to test the ability of a scientist to explain the latest results of her or his research to an engineer, so curious about all what is science, but not in the field of her or his expertise. So I would be very much listening to the ability to communicate in non-scientifically accurate terms, because it is in the context of what we have discussed before. So multidisciplinary teams delivering together. If a researcher is not in a position to communicate about, what he or she is doing, and she will never be able to contribute to the team effort. So communication for me is the key. So I'd be keen, rather, asking a specific question. For me, language communication skills are very important, and I would be checking on the understanding. I would probably ask what he or she understands with the principle of duty to dissent. It is fundamental at Airbus, really, that the speak up culture is exercised at all times. So you have the duty to dissent if you believe the team is taking a direction which could, for instance, compromise safety of an aircraft, which for us is, as I mentioned earlier, the first and utmost principle we work to.
I'm, of course, as someone who often travels by airplane, I'm actually reassured, Grazia, that at Airbus you're concerned about actually landing the aircraft. I think that's really important.
Yeah, always.
And I think it would be important to anyone listening here who's ever taken an airplane. When you're up there at 10,000 feet, or 10,000 meters, you would like to come down at some point, and safely as well. I also think that your answer gives us the opportunity to mention the fact that communication skills and dialogue skills are really important, particularly in multidisciplinary teams. Finding some common language where different people from different areas can talk to each other and understand each other is not so easy always. And I think that it's important to understand that that's going to be a key to success. It's a success factor in many, many areas. Maria, could you answer the same question? What key question would you be asking a candidate you would be hiring as a researcher, for example, in Biocenter Finland?
Yes, so hiring a postdoc, of course, from the CV, I would see the list of publications, etc. So the competence level, that's clear. But then I would ask for this mobility that we talked about. I would not hire somebody who has tried to answer the similar or same research questions that I am. So somebody who is from a sub-discipline would bring new knowledge into the team, and then of course would learn new issues in the team. I would also look for intellectual independence, evidence for intellectual independence, not forgetting teamwork, ability to work with others and enjoy that. I would search for passion. And for a researcher, passion is absolutely key. So I would like to explore, signs of this passionate drive, which is the key driver of a researcher. And then last but not least, I would also try to explore the attitude towards knowledge transfer, because of course, research and science aims at enlarging the knowledge base of mankind. But personally, I would also be interested in the translation of research findings into benefits for society.
Okay, thank you, Maria. Patrick, can you try to answer that question? Or maybe you've actually got a list of key questions that you try to ask to get at some of these.
Oh, yes. I have two key questions at the beginning. The first one is, what do you want to join us? I want to and not only, the answer must not be only Solvay is a big company. I want to understand if he join us, why he want to join us, and that he knows the company, he knows the mindset of the company, the purpose, and so on. So this is key. And most of the time, I'm surprised by the very low level of knowledge they have of the companies. So why do you want to hire someone who doesn't know the company in advance? The second is, of course, we are hiring most of the time, 95% are PhDs or postdocs. So the question is, what did you bring new to the world by your work in PhD or postdoc? And then I want to understand how it was his own or her own contribution. Most of the time, I also see people who have been doing, even in the PhD work, something where they have been some kind of execution of what their PhD mentor is doing. And because we try to know what the PhD meant, most of the time we also get people where we know the labs. So I want to really understand what has been his own contribution. And by some questions, you can get to this. These are really the two eliminatory questions. And then, of course, I would try to check about the mindset of the guy, the openness, the passion, as Maria was saying. Why does he want to do research in our teams, and what is his purpose for his career? With that, and of course, I dig in the scientific part, but with these three questions, I can really get an idea.
Okay, thank you, Patrick. What I sensed in the three remarks is something that, because we're trying to help also those people who are listening in and thinking about their own careers and whether research is also a career for them. Something that was struck me in all three of your responses was, explicitly in the response from Maria and from Patrick, was the question of independence and their own specific contribution in the research work. And in Grazia's case, the ability to explain clearly what it is that they have done and how they can present that to someone else. But I was just thinking, it came to mind a very small anecdote when I was listening to Patrick's remark about what did the researcher bring new to his previous projects. I was speaking a few years ago with a professor in a very prestigious university in the United States, and he was telling me it was a wonderful opportunity to be in such a prestigious university because he had wonderful doctoral students, and that intrigued me. And I said to him, "What is a wonderful doctoral student? What is an excellent doctoral student?" And he said, "Well, let me first tell you what a good doctoral student is." He said, "A good doctoral student is when you tell him to go into the lab and do something, he goes into the lab and he does it." And I said, "Well, what's an excellent doctoral student?" He said, "Well, an excellent doctoral student is you tell him to go into the lab to do something, and he goes into the lab and he does what you should have asked him to do." And I think that kind of intellectual independence is something that's appreciated in all levels, and I'm sure also in the industrial sector. And I sensed it also in many of your suggested key questions, that you're really looking for that in a candidate, that the person can bring his own personal, individual contribution. And I think that's just something everyone listening in on this session should keep in mind. You're not just following orders when you're in the research community, you're bringing new ideas. And I think that's really key. I have another question here, which I think would be a good way for each of you in a very short response to try to summarize your thinking. So the question is, what would be the 3 skills for researchers to have in the future? And that means that you can supply 3 words, and you can always use the words you've already used in your previous remarks, and that would allow us to also give everyone a very, very punchy idea of what we're looking for. So Grazia, I think you've already got your 3 words. So why don't you give them to us again?
So definitely fast, open, and focused.
How about you, Patrick?
Well, I will stick to science, to openness, and I will add, based on what you just said, Mike, disturbing. Exactly. We want people that disturb us with new ideas.
Okay, Maria?
That's a good point, Patrick. So I'll just add one. Awareness of impact to mankind, to society, on the work that we've done.
Okay, very good. So thank you very much. I have an interesting question here that just came through the list of questions. Is how can we balance the speed of development with the quality of development? And I think that, obviously, Grazia has this very, very good idea that all planes should be able to land. Okay, that's good. But that's a little bit vague, I guess, in terms of a general remark. Maybe we can start with Patrick on this and then go through to the other speakers. How do you balance the speed of development with the quality of development, in particular in your area where you're moving to, for example, changes in raw materials? Going from petroleum-based products to bio-based products, and you're changing some of the usage properties, as you mentioned. Sometimes they're not quite as good. How do you balance that as a research professional?
I would say the first point to balance is exigence on the results and the quality of the results. Now, the balance is because we are now developing tools that allow us to go faster with high throughput screening, with digital, with micro tools like microfluidics, robotics. We can do thousands of experiments a day in terms of basic experiments. Of course, at some time we will have to go to the pilot and to verify, but testing ideas is now very fast. Data management and artificial intelligence are also a way to monitor. And now we are relating the experiments to computers that define the next experiment. So that can work alone. So the capability that we have now to increase the speed makes us available in testing more experiments and going faster. Then, when you have these results, you have to verify and to go then to the real scale, to go to the applications lab, to go to pilot. And this is the exigence when we are developing the process. And of course, again, by validating the application with our customers. So it's natural, I would say. Since the last 10 years, we have developed the tools, and we will develop more and more, and it will go faster and faster. And the key is to connect all these tools that are used and the result that we get from these high throughput screenings and modeling to the real applications. And at this time, you cannot avoid any element based on safety. Back to what Grazia was saying, safety is key. We will not develop processes that are not safe, and based on the reality of the application and the solution that we can deliver. So it's really a matter again of integration from the bench scale to the real scale with the chemical engineers.
Okay, Maria, what would you say about this? I mean, is there, particularly in BioCenter Finland, you're doing a lot of research associated with biotechnologies, and they're quite controversial. I mean, sometimes people are concerned that some of these new technologies are just not quality. I mean, they're creating, in fact, the opposite. They're creating problems. How can you balance the speed of development of new technologies with quality?
Yes. First of all, legislation, of course, is key. And legislation comes always after discovery of new technologies. So there must be an interplay between the researchers community and then the political level who is responsible for legislation. And it's very important to have innovation-friendly legislation on new technologies. For instance, in the area of biobanking, we happen to have a very innovation-friendly legislation. But could I mention, Mike, another example, how to balance between excellence of science and speed. And I have a very particular example. So I'm chairing Technology Academy Finland, which gives out one of the most significant prizes for radical innovations, a global prize of 1 million euros. And these are really, the awardees have really changed the world via frontier research, where they have then made discoveries that can be used. And these are all also huge commercial successes. So how did these individuals balance between speed and excellence? They are all frontier researchers, but they did not remain at the frontier science research level, but they took a parallel path for applications. And now what happens is that the applications feed in new fundamental research questions, and then with the frontier research channel, they then again yield new applications. So the balance is here based on these parallel activities.
Thank you, Maria. Grazia, perhaps a couple of words on this question of balance between speed of development and quality of development.
I mean, Patrick and Maria really said it all. I can only add that we really do observe it also from industrial perspective. There seems to be researchers really keen on continuing their academic activities at a certain pace without necessarily thinking of implementation and industrialization as a key factor, and that's fine. But when you choose to join the industry as a researcher, you must be open also to elements of industrialization polluting in a way your research pace and timing, without any whatsoever compromise to research excellence. So this is exactly the question, right? We need to continue facing and monitoring very carefully when it comes to research in industry.
Okay, thank you, Grazia. Now, we have two related questions, and I'd like to ask them to the panel together, because these two questions, they concern more the academic community, so it may actually turn into a small dialogue between Maria and me. These two questions are very emblematic of a problem that we have, and maybe Finland has found the solution to this problem, and other countries have not. And the two questions are the following. So one of the questions is a plea, I guess, from a researcher, a young researcher, saying interdisciplinarity is not encouraged by professors or principal investigators, and they keep pushing on publishing as an objective. What do you think about that? That's one question. And the other is, even worse, single individual disciplines are associated with funding structures and the culture of competition. And, you know, Patrick knows this because we both work in France a lot, but I'm the former head of the French National Research Funding Agency, and we were very, very concerned about this, and we were very frustrated because we did not really find appropriate solutions to this. The interdisciplinary projects were systematically under-evaluated in terms of the peer review system. And we know, and I think that this is the question from these two young researchers, is aren't they going to have a problem if they espouse these new values that we're talking about here and then try to have a career in the academic sector? Maybe they should go to Finland, but I'm asking Maria, see if they're doing better in Finland than we are, for example, in France.
Well, first, let's talk about peer review and the cultural competition now, what concerns funding from outside of the university. So indeed, the Research Council should really make sure that their panels embrace this multidisciplinarity, because there are more and more multidisciplinary research proposals coming in. And so some countries do it better, some countries do it worse. I'm not at all praising Finland here, but I just know that this is a problem and a challenge that is very well understood in our Research Council. The other thing is then PI's say monodisciplinary applications. I think that we must renovate peer review in one way or another. So it never should be looking back. It should be looking into the future. What is the potential of the research proposal? And then the CV only then testifies that this person is able probably or maybe to carry out this very risky project. So more risk to have more gain. And I'm sure that the research councils in any country are struggling with these same questions. So then another issue, which, by the way, one detail that came to my mind, in the Nordic countries, not so much in Finland, but in Norway and Sweden, they are incorporating now, the Research Council is incorporating lay persons into the evaluation panels to look at the impact on society. So that's another story. It's not exactly, I mean, addressing this question that you posed to us from the audience, Mike. Now what concerns then monodisciplinary, selfish PIs and professors, and the problematics in universities. That's more severe because it changes with the change of generation. Do you have you found a solution to this particular problem in the university, Mike, yourself?
No.
Good question, hard question.
And actually, to be perfectly honest, this is sort of, I mean, this is like my mission, you know, as president of EuroScience. I would really like to promote openness. And, you know, our open forum is not called open for nothing. I mean, we really want to encourage this kind of openness. But what we see is that, unfortunately, the value systems in evaluation and reward systems in the academic community, which, as you pointed out correctly, you know, date from a development over 900 years, but in more recent times, there's been a real influence of what was very successful in the 20th century. The 20th century was the century that went from, I would say, generic research areas to very specialized reviews, specialized journals, specialized jargon, specialized communities, specialized peer review. And one of the difficulties of the 21st century is the enormous success of the 20th century. In the 20th century, this specialization and research communities was extremely successful. And so the people who are currently evaluating the younger researchers are people coming from a generation in which this sort of monoculture of individual disciplinary areas was really prized and rewarded. And so what we can hope is that there will be a change in the generational structure. I think that Patrick is probably a good observer of this because he's frequently looking at the academic community, but from the outside as an industrial person. And I know he knows the academic community in Europe quite well. Do you see any signs of hope, Patrick?
Oh, I'm very hopeful for the evolution of the academic community. I think again, academy is the roots of every development in science, and we need to have the highest level of development of science in the academy, of science in general. So what I see again, not all are equal, but the key laboratory, I'm speaking more about laboratories because, you know, we work more with laboratories than with universities at large. Universities are here to make the background, and then because we need PhDs, we work with labs. The one that, and it's always difficult because there are thousands of labs, and what we try to do is to see who is doing the most advanced research. And so we look to labs who are looking to new things, who are taking risks, starting new methodologies. And again, I see that the best will take off very easily. The other ones will still be able to survive but of course the world is more and more competitive in terms of funding, and we can discuss and I agree the peer reviewing sometimes have some is not always optimal, but you know that Mike, but the good labs always get rewarded at some time. What we must avoid is, of course, the effects, the announced effects, as I see sometimes, buzz, and really be back to the real science and the real quality. But I'm very I've been working with academia for more than 40 years, and I've seen always we are always able to detect the good labs, the good people, the leaders. And we need that in the young people. And again, we need young people that take risk in terms of going into new fields, in terms of bringing some new things in the world of academia, and we'll support that. And we need, as a global, not only industry but also the governments, we need to support these young people taking risks. That's
yes, yeah. Yes, I think what Maria Makarov talked about in this question of not looking backward but looking forward. I think that the positive note that I would see from this is the fact that some of the young researchers who are listening in on this session are concerned that they will not be able to express themselves completely in their interest for a multidisciplinary approach. And I think that's a good sign, because it means that some of them will enter into the community. And what I would suggest to them is to make a note of that now that they're young, and as they grow older, to maybe put it in a drawer someplace and look at it once in a while, and remember that when they were younger, they wanted this openness, and that they don't forget it as they go through their careers. And I agree with Maria that the generational changes are going to bring changes also in value systems and reward systems. Maybe, Grazia, perhaps you looking at this also from the outside, how do you see the academic community advancing? Maybe you're more optimistic than I am, or you think that maybe progress can be made more quickly?
Well, I wanted first of all to give our Airbus dimension to the question. We have an equivalent dilemma when it comes to career paths within the company. And we are putting a lot of attention into making sure that the management career path, which does require a certain versatility and multi-skill, let's say, approach, is not the only one getting also rewarded towards the expert's career path, right? Where we have many of our scientists in this career path. It is sometimes an expert may be less visible than a manager. Nonetheless, equal opportunities for further development, also in terms of remuneration, shall be given to both. So it is, let's say, a slightly different angle to the question, but it's something we're very much aware of. Again, we need everyone. We need the multi-skill talents, and we need the experts. So.
Okay, we have 3 minutes left, and there are 3 of you on the panel. So each of you gets 1 minute to send out a key message. So Maria?
I think the world has changed already. So the citizens, the students, younger generation, older generation, we now are quite aware of the challenges that we have in this world. And was it Grazia, you who mentioned the post-pandemic world? So the first thing is, of course, to gain awareness. And now then, education and how you do it as a student, etc., how you orient your career then, wanting to stay in academia as a researcher and then going out to industry, to other sectors, to society. I have great hope that we are at the verge of real expansion of this change. I'm very hopeful.
Okay, thank you, Maria. Patrick?
Well, for young researchers, define what you want to do with your life. Define your purpose in professional life, but also your personal life. And go with it, and don't hesitate to disturb the people, to come with ideas. Of course, do everything you need to do to get the basics so that you can be a good scientist, but you can also evolve afterwards in business or whatever. So define what you want to do, and we are ready to discuss with you about that anytime.
Okay, thank you, Patrick. So Grazia, you have 1.5 minutes.
The world is uncertain. There's a lot of complexity in our world today. And again, there's still many reasons to be excited about the future of research. So stand up for science, harness on our collective intelligent ingenuity to really continue driving progress in the name of science. And indeed, we will change the world into a better place.
Okay, thank you very much to all 3 of you for engaging in this conversation with me, and also being open to answering the questions from some of those who have been logged into our virtual session today. I think that we can draw as a conclusion from this a tremendous willingness on the part of all of us here to try to open up and encourage dialogue, and also I think an optimistic view, because everyone is aware now that this is how we are going to be able to make progress and quality development in the future. So all of those out there, all of you young people out there who are looking for sense and value in what you're doing in your careers, be aware that also those of us here who are potential employers share your values and your ideas of what should be done going forward. So thank you once again to everyone. I'm very, very happy to have moderated this discussion, and thank once again the panel members for their contributions. So bye-bye, everyone.
Thank you, Mike.
Thank you, Mike. Thanks all.
Thank you.
Bye. Bye-bye.
Bye-bye.